Welcome to this explainer. Okay, let's just validate a very specific, very real frustration right out of the gate. You've built a RAG system, Retrieval Augmented Generation, and it works brilliantly for some queries, but then it just completely hallucinates or completely fails on like 40% of your real-world questions. It's incredibly annoying, right? Well, today, we're going to fix that. We are taking that naive, out-of-the-box prototype and transforming it into a hardened, production-ready system.
So we're going to climb an upgrade ladder today. We'll start by pinpointing the retrieval bottleneck, then move on to smarter chunking strategies, step up to search and re-ranking, lock everything down with systematic evaluation, and finally, learn how to detect context drift. This is your blueprint for taking back total engineering control.
All right, diving right into Section 1, the retrieval bottleneck. Let's find the true source of the failure.
When your system gives a wildly wrong answer, there is one golden diagnostic question elite teams always ask before they even think about messing with the prompt. Was the right chunk actually in the retrieved context? Seriously, if the relevant information was never pulled from your documents to begin with, it literally does not matter if you're using the most advanced, expensive AI in the world. It can't generate an answer from data it simply doesn't have. So rule number 1, always inspect your retrieval pipeline first.
Now, the numbers on this are honestly staggering. A massive 85% of all failures live entirely upstream of generation. Just think about that. We are heavily bottlenecked at bad chunking, which is causing 40% of failures, and retrieval misses causing another 30%. Ranking issues take up 10%. Only 15% of the time is it actually a generation failure where the language model fumbles good context. This is exactly why we need to stop tweaking prompts and start investing our effort where the failures actually live.
Moving right along to Section 2, Smarter Chunking Strategies. It's time to respect the document and fix that 40% bug layer.
We really need to contrast the naive chunking you probably started with against structure-aware chunking. Naive chunking just mechanically chops text every, say, 800 tokens. It's like using a meat cleaver on a book. It completely ignores whether it's slicing a sentence in half or separating a header from its paragraph. Structure-aware chunking, though, it listens to the natural boundaries of your documents. It respects things like markdown headers, HTML tags, and code blocks. By doing this, attaching metadata like refund policy, page 3, becomes a massive retrieval advantage. You're giving the system the exact structural context it desperately needs.
And if you want to seriously level up, you've got to look at contextual chunking. This is a brilliant technique pioneered by Anthropic, and it's been reported to slash retrieval failure rates by roughly 50%. So instead of just embedding raw text, you use a small, fast language model to write a quick summary of how that specific chunk fits into the entire document. You prepend that summary, embed them together, and boom. Suddenly a random isolated paragraph about late fees is contextually linked to the Enterprise Client Contract of 2025. It makes accurate retrieval dramatically easier.
Okay, Section 3, Search and Re-ranking. Let's talk about catching those misses.
So, why does pure vector search eventually let you down? Well, dense vector search is amazing for semantics. It intrinsically knows that refund and reimbursement are related, but it is frankly terrible at exact keyword matches. If a user searches for order #1234, vector search might just return a bunch of documents about orders in general. Sparse search, like BM25, is the exact opposite. It excels at finding those precise, rare keywords. This is exactly why we have to combine them to create hybrid retrieval. You run both in parallel, merge the results, and cover both semantic intent and exact phrasing. It is the absolute 2026 production default for a reason.
Here's the playbook for implementing this, the canonical two-stage pipeline. Stage 1 uses that fast hybrid retrieval we just covered to cast a super wide net, grabbing, let's say, the top 50 candidates. But those results are based on pretty shallow similarity scoring. So Stage 2 brings in the heavy artillery, cross-encoders. Now, cross-encoders are way too slow to run on your entire database, but they are incredibly precise. They directly examine how the specific words in the query relate to the specific words in the document. They take those 50 candidates and meticulously re-rank them down to the absolute best top 5. It completely fixes your ranking issues.
And the craziest part? Hitting this elite, production-grade quality level only costs about half a cent per query at scale. I mean, when you weigh a fraction of a penny against a massive 15 to 30% jump in system accuracy, the ROI is an absolute no-brainer. It's quite literally the difference between a frustrating user experience and a completely magical one.
Which brings us to Section 4, Systematic Evaluation.
Time to measure the impact.
We absolutely have to abandon vibes-based tuning. The pattern of measure, change, measure is the discipline that separates real production work from just fiddling with prompts. If you swap out a chunking strategy and just run 2 or 3 test queries to see if it kind of feels better, well, you aren't really engineering, you're just guessing. You must evaluate your changes against a dedicated test set before and after every single architectural tweak.
And to do that properly, we use frameworks like Ragus. It acts as the perfect diagnostic flowchart. It doesn't just say, hey, your system is failing. It tells you exactly where. Low faithfulness score? Your model is hallucinating outside the context. Fix your prompt. Low context precision? You're bringing back irrelevant garbage. Go fix your retrieval or re-ranking layer. It takes debugging from a frustrating guessing game and turns it into an exact science.
Finally, Section 5, Detecting Context Drift. The messy operational reality of going live.
Because here's the truth. Even the most perfect system will quietly rot over time if you aren't actively monitoring for context drift. And it comes in 3 insidious forms. First is schema drift. Maybe the team making your company's PDFs changes their layout overnight, which completely breaks your structure-aware chunking. Second is semantic drift. Imagine your company rebrands and changes refund to return in all the docs, but users are still searching for refund. Your system is going to miss those connections. And third, the absolute worst one, staleness drift. Last year's HR policy is still sitting in the index right next to this year's, and the AI has absolutely no clue which one is the current truth. You've got to build continuous monitoring into your operations to catch these before your users do. So, as we wrap up this explainer, I want to leave you with a thought. Very soon, these language models are going to start directing their own complex, multi-step retrieval loops. But as that wave approaches, ask yourself, is your pipeline actually ready for agentic RAG? Upgrading your chunking, combining your search methods, and rigorously evaluating your results today is how you built the bulletproof data pipeline required for the autonomous agents of tomorrow. Thanks so much for joining us, and keep building.